Hello students. So last class we have solved few of the circuit. In fact, we solved few of the resistance connection, complex connection by using series and parallel combination concept. But I'm giving you one more circuit over here. Let's check that whether it can be solved by using the series and parallel combination or not. So the circuit is here. This is your R, and each resistance is R that is connected to the circuit. Okay. So let's check that, and these 2 points are A and this point is B, and these are the resistance that are connected to the circuit. We are required to find out the equivalent resistance between A and B. So as we know that we have to name those points, all the points across each resistor should be named and they should be arranged properly. So this point is having a name of D, and this is C, D, and this point is E. So how many points are there? 5 points. So if you will try to arrange it like this, AB, and all the intermediary points, I'm going to put it here like C, D, and E. We can find A to C is R, between C and D it is R, and between D and B it is going to be R. I'm not going to draw it for a long. And again we found one more resistance that is connected between C and B also R. So can you find it is going to be quite difficult and it is complex. So how to solve this kind of circuit? So for solving this kind of circuit, we use a concept that is called as concept of symmetry. Concept of symmetry. But before jumping into the concept of symmetry concept, we should know that which are the circuit which can be considered as a symmetric circuit. As a layman's language, I can say that the symmetric circuit are those circuits, those are looking alike from the input side as well as from the output side. So if you'll see that this is the input side and this is the output side, so the combinations are looking similar to each other. That you can see that 3 resistors are connected here and 3 resistors are connected here. Okay, so we will be using the concept of symmetry over here to solve this kind of circuit. So before that, we should understand that what are the types of symmetric are there and how to use that. For that, we have to follow a few of the rules to do it. So symmetry, here we are going to use two kinds of symmetry. One is called as vertical plane of symmetry, or that is called as VPS. We will do few of the example on it so that we can understand it in a better way. So this is called as VPS, or the vertical plane of symmetry. So when such symmetry happens, so what are the points that we have to consider to solve the circuit easily? Let's see. Okay, so let's see it. If I say there are 2 points across which we are finding out vertical plane of symmetry. So how to find out this vertical plane of symmetry? Let's take an example. This point is A, this point is B, and a bunch of resistances are connected between A and B. I'm just putting a string line, and you cut this equally by drawing a perpendicular over here. By drawing a perpendicular, and you draw it in such a way that as if a mirror is placed over here. If the left hand side is exactly a mirror image of the right hand side or the vice versa, so in that case we call it as vertical plane of symmetry exists. So the few of the points that we have to consider, there are 2 points that I'm going to say. One is points on the VPS have the same potential. Points on the vertical plane of symmetry, points on the vertical plane of symmetry have same potential. Similarly, the second point says that the branches which are mirror image, we will do it, branches which are mirror image about the BPS have the same current. About the BPS have the same current. We'll discuss it one by one. So these are the 2 points about the vertical plane of symmetry. Let's move to the next part, that is horizontal plane of symmetry. That is called as HPS. So the next concept is horizontal plane of symmetry. This is your horizontal plane of symmetry, or we call it as HPS. If this is found in a symmetric circuit, then what are the points you have to take care of? If the horizontal plane of symmetry is found between any 2 points about which we wish to find out the equivalent resistance, so this point you have to place a plane mirror over here. So this is exactly the below part is the exactly a mirror image of the upper part. So the points that has to be considered over here is points which are mirror image about the HPS, which are the mirror image about the horizontal plane of symmetry, have same potential. They have same potential, and as we know that any 2 points which are having same potential, so any circuit element that has been connected in between, like capacitor, resistor, so they should have no effect. They should have no effect. So let us move to that circuit and see that how that circuit can be solved in an easier manner that we have discussed initially. So this was the given circuit, right? Which seemed to be very difficult for us to solve it by using the general rule of series and parallel combination. So this point used to be A and this point used to be B. R, 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 R. And so this is a symmetric circuit. Already we have discussed why it is symmetric. Now it is the turn to check that whether it is horizontal plane of symmetry or vertical plane of symmetry, right? This is actually has both plane of symmetry, but I am using horizontal plane of symmetry, example of horizontal plane of symmetry, and we'll use the concept as well. So if we'll join these 2 points and we'll try to put a mirror over here, we can see that the upper part is exactly the mirror image of the lower part and vice versa. So we will come to the point that, so this is your horizontal plane and this is the vertical plane. Sorry, horizontal plane, and this part is the mirror image of the below part. Now, what is the rule of HPS says? So we are having HPS is present over here. It says that the points which are the mirror image, okay, this point is the mirror image of this point. This point is the mirror image of this point. If I'm going to name this point as C and this point as D, so they must have equal potential. If they are having equal potential, so we can write the potential of point C is equal to the potential of point D. So anything that is connected between them are going to be ineffective, So see how our circuit is becoming very easy now. This point is A and very simple. This one is R, this is R, and this one is directly we can write if these two are gone. So this R and this R will become series. So it will become 2R, and here it is R and R. And this point is B. So see how easy it is. R plus R, it is 2R, 2R and 2R. So final answer is, so 3 2R are in parallel with each other. So final answer is equal to 2R by 3. So the final answer is equal to 2R by 3. Clear? So this Circuit has become so simple now. Now let us move to one more question. There also we will be checking for the HPS as well as for the VPS. In this circuit, the circuit is this one. Though this you can solve it by using the normal methods, but anyways, we will solve it by using symmetry. So this point is A and this one is B. Now it is given each resistor is having equal resistance. So let me first check that whether what kind of symmetry is going to be applied over here. If I'll try to have the HPS, so HPS needs to be like this. We have to place a mirror over here. So just below it, we are not having anything. We are not having anything, right? So that means HPS is not applicable here, right? So now we have to check for the VPS. So I'm going to put a vertical line over here. I'm going to put a vertical line over here. If I put a vertical line over here, so I'll show you that how to solve the BPS circuit in two ways. So BPS is existing because if I'm going to put it as a mirror image, we can see that this left side is exactly a mirror image of the right hand side. So BPS is present. BPS is there. So what are the rules of BPS? Points on BPS have same potential. Points on BPS has same potential. If we are going to apply it over here, so what is there in it now? Nothing. This point is C, this point is D, and this point is E. So they all will have equal potential. If it is there, so we can simply remove this part from the picture, and how much we will be getting that this point is A, this point is B. Just above it we are having R and R are connected. Then here it is R and R are connected, and just below it we are having one more R. So this R and R is going to give you 2R, and here it is 2R, and here it is R. So these two are in parallel with each other and their combination is in parallel with R. As we know that if two equal resistances are in parallel with each other, so they are going to give you R. Now this R and this R is parallel, so final answer is R by 2. Final answer is R by 2. Hope it is very clear to everyone that how the symmetry is going to help you to find out the different type of circuit easily, or to solve the different type of circuit easily. So let's do one more circuit. Let's solve one more circuit over here. I'm having one more circuit. The circuit is so all are having equal resistances. Similarly, we are required to find out the equivalent resistance between A and B. Of course, if we are going to do it for by using the common methods, it is going to be really difficult. Symmetric, how it is looking like from the beginning, it's looking exactly like from the right hand side also. Fine. So let's check for the symmetry. I'm checking it for HPS. Below it, nothing is there, so HPS is not applicable. Let's do it for VPS. VPS, exactly. So just look at here, how to solve this kind of circuit. You are having only 2 points over here. So it says that, but there is no resistances are connected in between. So that means I'm dividing this circuit equally into two parts. So step 1, completely detach this part left hand side from the right hand side, and let's draw it. This is R, this one is R, and this one is also R. And here instead of writing R, just exactly break it as R by 2 and R by 2. So I'm placing R by 2 here and join these 2 points by a straight conducting wire because they both are having equal potential. I'm going to name this point as C. So if this point is C, so this one is also C. So first of all, we have to find out the equivalent resistance between A and C. What is that? So how to find out the equivalent resistance? It is easy now. A and C, just put it outside. This point is, let it be some X. So I'm putting it in between X. So between A and X, we have R. Between X and C, we have R by 2. Between X and C, we are having one more R because they are parallel. And between A and C, we are having R. So if we will solve it, so R by 2 and R, they both are parallel to each other. So they will give us R into R by 2 divided by R plus R by 2. So this is R square by 2 into 3R. So this is R by 3. This one is R by 3. R by 3 and R are in series and their combination is in parallel with R. So we can write R by 3 plus R. So this one is 4R by 3. Now this 4R by 3 is in parallel with R. So we do find out the equivalent resistance between A and C is 4R by 3 into R divided by 4R by 3 plus R. So how much it is coming? It is coming as 4R square by 3 into 3 divided by 7R. So this one is 4R by 7. I'm putting it in a bracket, in a circle. But we want to find out between A and B. What I told you, we are breaking this circuit into equally two parts. So I'm using one more color of pen to show you. If it is broken equally into two parts, so we can write RAB is nothing. It is 2 times of RAC. It is 2 times of RAC, right? So final answer is 8R by 7. Final answer is 8R by 7. So this is the answer to this part. So probably it is very much clear to all of us at how to solve this kind of circuit. And the last one that I'm going to take an example of the similar type of circuit which is a very quite popular also. So let me draw the circuit first. So the circuit is this one is an 1 ohm resistance. But this time we have to be a little bit cautious about it because we have to find out this is 2 ohm. This one is also 2 ohm. This is 2 ohm. Now we are having one more point here that is 1 ohm. And here it is also 1 ohm. This one is also 1 ohm. And we are having this resistor is 2 ohm and this is 2 ohm. And there are 2 points which are given as A and B. And we are required to find out the equivalent resistance between point A and B. Let's find it out. Let's see that. What kind of symmetry exists over here? What kind of symmetry exists over here? Before that, I'm going to name those points which are not, other points also. I'm going to name those points. I'm going to name this point as P. This point is Q. This point is R. This point I'm going to name it as S. I think every point across each register is named now. across each register is named. Now let us find out the kind of symmetry. Now the point is A and B. If you draw it on a plain paper, you just turn the paper and see that if you draw a line over here between A and B like this and put a perpendicular line, definitely it is not VPS. Definitely it is not VPS, because if I draw exactly a line that is cutting both of it, but this is upper part is not at all the mirror image of the lower part. Now this line that is joining A and B, and we found HPS is present over here. Horizontal plane of symmetry is there because left hand side is exactly a mirror image of the right hand side. And what is the rule of our HPS? What is the rule of our HPS? The HPS says that the points which are the mirror image about HPS. Rule for HPS is very simple, that points which are the mirror image have same potential. They have same potential. So let us find those points which are having the mirror image of the other one. Which are the mirror image of the other one? Yes, I found the point R and S. I found the points, and those points, one of those points is R and its mirror image is S. So I can directly write down the BPA should be equal to BS. BP is equal to VS. Similarly, the other point I found it as for P and Q. The other point is P and Q. P and Q. So we will be writing it as Vp is equal to Vq. So what is the meaning of it? That means any resistor that is connected in between them will have no effect. Will have no effect. Let's remove them. This is gone and this one is gone. Now see the circuit, how simple it is becoming now. This one is 1, right? This point is B. This one is A. Okay, so we can write here point R, but it is connected to it with a resistance of 2 ohm. This one is 2, this point is S. This is gone, no? This one is gone. Now, this point is P, but this is not there, and we are having Q over here, and they are not connected, and now the circuit has been reduced like this. This one is 2 ohm. So I'm going to round everything around it, and these 2 points as 1, and this one is 1, right? So let's solve it. Can we say this 2 and this one are in series, and this one is, because if the current moves from A to B, so the total current is I, so it is going to be divided like this: I1, I2 and I3, right? So this I1 is flowing in 2 ohm, it is also flowing in 1 ohm, and it is also flowing in 2 ohm, right? So this one is your I1. Similarly, this is I2 and this one is I3. This is also I3. So we can say this 2, this 1 and this 2, they all are in series. They all are in series and their combinations are in parallel with 1 ohm. So effectively the circuit can be redrawn as A and B, and this one is 2 plus 2 plus 1, that is 5, and this one is 1 and this one is 5. So the equivalent resistance between them is 1 by RAB equal to 1 by 1 plus 1 by 5 plus 1 by 5. So this is 5 and 5 plus 2, that is 7 by 5. So final answer is equal to 5 by 7. Final answer is coming out to be 5 by 7. So final answer, I am putting it in a box, that is 5 by 7 ohm is the correct answer.